Here's Bayes' rule, which you should recall from your prerequisite classes. Bayes' rule basically states that we can take one conditional probability and express it as the product of three other probabilities. We have two unconditional probabilities as well as another conditional probability. By itself, this doesn't seem to help much because we're saying that in order to calculate the one on the left-hand side, we need three other probabilities from the right-hand side. But it's often the case that what's on the left-hand side is difficult to calculate. For example, what is the correct answer or label given some data that we have at our disposal? Let's go ahead and colorize Bayes' rule to understand how it applies in machine learning. Let's just think about the case of a binary classification problem where y can be positive or negative. Let's think of the case of the positive and look at this term over here. P of y in this case is the prior probability that an instance is going to be positive. So we could look over the entire data set and find out how likely is the positive case compared to the negative case. Now that we've established what our prior belief in the outcomes are, we observe some data. We need to condition the probability of the data on our prior beliefs. We're going to call this the likelihood. That is the likelihood of the data given our prior belief. However, there are many different types of data that we can observe, and so we'll need to also normalize for how likely the data that we observed actually is. We're going to call this the marginal. Putting these three terms together, we can update our belief in the actual outcome itself. That is our y, given the data that we've actually observed. We're going to call this the posterior. Just to make it a little bit more clear, we've put all of the variables here on the slide so that you can see what we're talking about. So that gives us the Bayes part of the naive Bayes algorithm. The fact that Bayes' rule allows us to update our prior probabilities or beliefs in a particular class label, let's say a positive class, given data that we've seen. But what makes it naive? To understand that, we first have to come back to the probability product rule, also known as the chain rule. This states that a joint probability of several different events, here we can think of the events being particular feature values, for example, for the first feature all the way up to the nth feature. These joint probabilities can be decomposed in several different ways. For example, we can take the unconditional probability of x1 having a particular value and condition it on the values of x2 through xn. We don't have to decompose it that way. We can take any of the variables in this region and then pull it out in this way. But the interesting part about this is we can repeatedly apply this idea. We can write, for example, pulling x1 out of the joint probability and putting it in the first term and conditioning on the rest, and then do the same thing for just this part of the equation by pulling out x2 and conditioning it on x3 through the rest, and then pulling out x3, conditioning it on x4 and the rest, all the way until we get a single unconditional probability for xn. And this type of factorization holds for any ordering of the features because at any point in time, we can pull out any of the remaining features in the joint probability and write it out this way. So this gets us to naive Bayes. Naive Bayes is basically just taking the likelihood term that we saw in the Bayes formula and replacing it with the conditional product rule that we saw earlier. The idea behind that is we're just going to change this into a form that allows us to assert conditional independence between each of the features. Instead of having a joint probability of each of these things, we're just going to factor each one of these out and assume that each feature is conditionally independent of all the others. This gets us a notion of the posterior probability in this case. One thing that you might be puzzled about is about where the marginal term went. We had a red term before, but in this formulation, it's gone. So I'd like you to think about where did it go?